Hey y'all, so at this point we have talked about parallelograms, we've talked about rhombi, rhombuses, rectangles, and squares. Today you're going to learn about kites as well as trapezoids, and that should do it for our quadrilaterals. Tomorrow you're going to take a quiz on the properties of quadrilaterals, so I thought what better time but to review all the stuff we've learned so far. So this is number 45, notes page 45. Two pairs of parallel sides, then you know it's a parallelogram. One property of a parallelogram, opposite sides are congruent. This should have another equal sign under it. Also, opposite angles are congruent, and then, of course, same side interior angles. These two angles are going to add up to 180 degrees, and our diagonals bisect each other. So you need this notes page to be able to know what to use, what rule or property to use in order to solve some problems. So if I look at number 1, I see that I'm going to apply the fact that opposite angles are equal to each other. So I'm going to set up 17x plus 2 equals 70. Get my handy dandy calculator, and I'm going to be taking 68 divided by 17, and I get 4. Because 17x equals 68, so x equals 4. And since they're asking me to solve for x, I'm good to go. For number 2, these angles are not opposite each other, but they're on the same side. So this is going to be same side interior angles. So I'm going to add them all up, and they're going to equal 180. And so I've got 7x plus, and I'm just going to combine my like terms, 24 plus 62 plus 10, well that's 96, and this is going to equal 180. So if I subtract out 96, I get 84, so 7x equals 84. Divide that by 7, and my answer is x equals 12. Now, what do we know about the this problem number 3 is exactly like problem number 2. This is going to be same side interior angles. So you're going to add them all up and equal it to 180. And then I noticed that number 4 is just like number 1. Except we don't have opposite angles, we have opposite sides, but we know they're congruent to each other. So you're going to set them equal to each other. 17 equals 2x minus 7. And then lastly, we have this diagonals to worry about. And so what we know from our previous notes is that diagonals bisect each other. So that means that they cut each other in half, basically. So this side is congruent to this side, and this side is congruent to this side. So what information do we have? We have that BH, this part right here, is equal to 19. I always like to label my diagram. And then I know that FH, which is the whole thing, is equal to 37x plus 1. And I want to know what is x. Well, if I know this side is 19, that's 9 out of 7, then I know this side is also 19. Because they bisect each other. So 19 times 2 is 38. So I'm going to set this thing up. And it looks like I'm going to get 1. 38 equals 37x plus 1. Subtract the 1 out, divide by 37. And in fact, x equals 1. However, if you didn't know the properties of parallelograms, you won't do well on the test tomorrow, or on the quiz tomorrow. So definitely make sure you study those and look them over. Let's quickly review our other quadrilaterals. So we've got a rectangle. Rectangles, opposite sides are congruent. All the angles are 90 degrees. And the diagonals are congruent, and they bisect each other. Okay. A rhombus is like a square, kind of on an angle. All the sides are congruent, and the opposite angles are congruent. And then you can also apply the same side interiors theorem. So the diagonals bisect each other, but they're not congruent to each other. So that's how it's unlike a rectangle or a square. And they also form perpendicular angles, the diagonals do. So the angles don't form perpendicular angles, but the diagonals do. And so a square basically has all the characteristics of a parallelogram, all of them. Bisecting, congruent, perpendicular diagonals, all angles are 90 degrees and all the sides are congruent. All right, so let's review and look at a couple problems with this. So here we've got, this is a rhombus. So first of all, what type of angle is PLA? Well, that is an obtuse angle. What type of triangle is PEN? Well, we know that these angles make a 90-degree angle, so that would be a right triangle. Is PEN congruent to AEL? And that is a yes, because they are. Is it true that PA is congruent to NL? So PA is this line, and NL, no. They're not congruent. That's the one characteristic. So we want to find the measure of all the angles inside. Well, we know that our diagonals bisect, so this is also going to be 34. We know that opposite angles are congruent. So if this whole angle here is 68, then this whole angle here is 68, which means each of those angles inside is 34. 34 plus 34, is that right? 34 plus 34 equals 68, yes. All right, now on the other side, there's a couple ways you can go about doing this. If we know that this angle is 34, and this one's 90, well, to find this angle, you could just take 180, because we're looking at this triangle here. So 180 minus 34 minus 90 will give us the angle L. Minus 34 minus 90, and you get 56. So this angle L is 56. Okay? And I know that this angle then is also going to be 56. And then I know that these angles over here, this whole angle together is 56 plus 56, which is 112. Now if I wanted to double check, I could add them all up. So it'd be 112 times 2, which is 224, plus 68 times 2. And I get 360 degrees. And remember, the angles in all quadrilaterals add up to 360 degrees. So at this point, you should be working on N4, N5, N6, and N7. And now let's get ready to take some new notes for today. You have to be able to do all of these things on the quiz tomorrow. Okay, so today we're going to look at yet 2 more quadrilaterals. So we've got a total of, what is that? 6 quadrilaterals that we've looked at. And these are trapezoids. Trapezoids are not parallelograms because they only have one set of parallel sides. So a trapezoid has one set of parallel sides. The angles, again, it is a quadrilateral, so all angles equal 360 degrees. And a diagonal is a diagonal. We'll talk about the special characteristics in a minute. So here we've got a trapezoid. And one characteristic of a trapezoid, so again, remember this is not a parallelogram because there's only one set of parallel sides. All right, is that the legs of a trapezoid are congruent. So that's what we call the legs of a trapezoid. They're the parts that are not congruent. Legs of a trapezoid are congruent to each other. Okay? So if you know the side of one, you can set the other one equal to each other. So blank equals blank. All right, another thing we know about a trapezoid is that the base angles are congruent. So these angles are base angles. They're congruent to each other. Now if we turn this thing around, then these would be the base angles. So they're also congruent to each other. And then we can also apply the SSI theorem, same side interior, because we have parallel lines. You can say that same side interior angles equal 180 degrees. And then lastly, let's say I labeled this trapezoid A, B, C, D. I can say that this side right here, this diagonal, excuse me, is congruent to this angle. So the diagonals, let me write this in red for those of you that are a little bit OCD. So your diagonals are congruent. So AC, line segment AC, is congruent to BD. Okay? Those are the characteristics of a trapezoid. You're going to practice that today, but you need to know it for the quiz tomorrow. All right, a kite. Not the best weather today to fly a kite, but it's a fun thing to do. One thing to know is that the consecutive, so that means consecutive means one after the other. So if I said you count in consecutive order, that's 1, 2, 3, 4. What are consecutive even integers? 2, 4, 6, 8. You don't skip anything. You go right in order. So consecutive sides. So this side is consecutive to this side, and they are congruent to each other. This side here to the side here are congruent to each other. So, this one, okay. Consecutive sides are congruent. Okay, secondly, you can say left and right angles are congruent. So if I said this is my left angle, this is my right angle, they're congruent. Now if I turned it, the other ones would be too. And then lastly, the diagonals, they actually bisect. They bisect an angle. I guess I can't scroll down. So they're going to bisect this angle here and down here as well. So they bisect. And they're perpendicular. Now, these two sides are also going to be congruent to each other. So they bisect one side, they bisect the angle, and they're perpendicular to each other. All right, let's dig in. Let's apply these properties to solve some problems. All right, starting out. We're looking at angle R. So the first thing you want to look at is the relationship between angle R and angle S. And what you should notice is that they are same side interior angles equal 180 degrees. So all you have to do is take 180 minus 65, and that gives you 115. Please note, if you don't know the property, this will be difficult. But if you're studying, you know the properties, so we're good to go. All right, second, we want to name all the base angles of the trapezoid. So first of all, if I know this one's 70, I know this one's 70. And if I want to figure out this one down here, I can apply same side interior angles and figure out that this angle is 110. And because I know this angle is 110, I know this base angle is also 110. Again, fairly simple unless you don't study your stuff. Here we go again. We've got this angle, and we want to know this one right here. Well, first of all, I know that angle F is going to be 60 because they're base angles. So here to find this one, that's same side interior. So that's 180 minus 60, which is 120. So I know this one's 120 and this one's 120 because they're base angles. And then I know this side is 15, and I know this side is congruent. So if I want to know this side length right here, it's also 15. Here we go. If I know that KM is 22, well, I know the diagonals of a trapezoid are congruent. So therefore, if KM is 22, JL is also 22. Pause the video, work the next two, come back and see if you get the right answers. Okay, go ahead and check your answers. Pause the video if you need to, and then try this problem.